Hello everyone, how are you all? I hope you all will be fine. So welcome to my channel and let's do physics with Lipsy Rana. So today we will discuss the topic the properties of electric field lines. So this topic is very simple, very easy, and this is very similar to the earlier topic which we have done in our previous chapter. That is the properties of electric charges. These are the 4 to 5 lines and 4 to 5 points, and I will explain you in an easy way. So our first point, so let's do our first point. Our first point is electric field lines are continuous and they never form closed loops as they always start from positive charge and end at negative charge. So I will explain you this. What is this? Electric field lines, which we have discussed earlier, that if there is a positive charge, then electric field lines are always point away from the positive charge. Like we will put the arrows here. So arrows will be away from the positive charge. If there is a negative charge, then electric field lines, there are what electric field lines are the arrows which are moved towards the negative charge, like this. So these are these looks like the straight line when the charges are separate, but when we close two charges, one is positive and one is negative, so these lines will be like this. These will be the curved lines. These will be the curved lines, curved. So they will never make loops, closed loops like this. If because their starting and ending points are different, that's why they never make the loops, because in a closed loop the starting point and end point will be the same. When we are talking about the circle, when we take the one point and anything starts from one point and we make the circle, and that point, that thing will end at the same point. So in a circle the end point and starting point will be the same. That makes it a closed loop. That makes the circle a closed loop. But in electric field line, it always start from the positive end. It always start from the positive thing and end at the negative charge. Start from the positive charge and end at the negative charge. That's why. So this is the reason they never make the closed loops. So first point, I will repeat the first point again. These lines are continuous. These lines are in continuous form. This never happens that if there are charges, then there will be no electric field lines. This will never happen. If there are charges, definitely there will be the continuous electric field lines. This doesn't happen that after 5 minutes, if charges are there, after 5 minutes the electric field lines will absent. This doesn't happen. So that's why it is talking about the continuous word here. So these lines are continuous and they never form closed loops. They never form closed loops because their starting point and end points are different, as because they always start from positive charge and end at negative charge. I think first point is very clear, that these lines are continuous and never form the closed loops because their starting point is positive charge and their end point is negative charge. That's why, because in the closed loop, when the any charge or any point, anything, we are talking about anything, if it starts from a certain point, then it will end at the same point. So that's why electric field lines doesn't form any closed loops. So now moving to the second point, two electric field lines never cross each other. Two electric field lines like this. If first line is this, then second line will not cross to the first line. So these lines never cross to each other. Why? What is the reason behind this? It can be corrected in the exam in 2 marks, that why two electric field lines never cross each other. Because if they cross each other, then at the point of intersection there will be two tangents. First in this direction, second in this direction. If we draw tangent at the point of intersection, the direction of two tangents will be different, but this doesn't happen. This can't be possible that at single point there will be two directions of electric field. At one point there will be only one direction of electric field. So this doesn't happen. That's why two electric lines do not cross each other. Okay, I think आपको ये दोनों points clear हो गए. Now moving to our third point, that is tangent. I have already discussed this point earlier, that tangent to electric field line at any point gives the direction of electric field at that point. If suppose electric field line is in curved form, at any point, because if it is in curved form, at any point the direction will be changing, because when we draw the curve, the direction is continuously changing. So how we can find out the direction of electric field at particular point? Suppose we take this point P and we need to find out the direction of electric field at point P, what we will do, we will draw a tangent at point P. We will draw a tangent at point P. That tangent will give the direction of electric field at that point on electric field line. So electric field lines helps us to find out the direction at particular point. Okay. So I think the third point is also clear to all of you. Our fourth point is these lines start or end on the surface of the conductor normally. This means normally means at 90 degree. If we have the conductor, suppose, so if one end is positive, another end is negative. So when it starts from this positive end, it will make 90 degree angle. It will start from the conductor, from the one end of the conductor normally, and also end at the conductor normally. When it ends at the another end of the conductor, it will again makes 90 degree angle. Normal means 90 degree. So these lines start or end on the surface of conductor normally. Okay. Fifth point is electric field lines exert a lateral pressure because of the repulsion between two unlike charges. When we take the two charges, one is positive, another is negative. I have drawn earlier the picture of electric field line like this. Okay, but when we take the system of two unlike charges, I will draw the diagram. When we take the system of two unlike charges, sorry, unlike, it's not unlike, it's like charges. Suppose it is plus, two like charges, then it will be like this. So their look will be like this because of the lateral pressure. When we take two like charges, because of the repulsion force between these two charges, these electric field lines also exert a lateral pressure. Because of lateral pressure, they will not combine, they will like this. They will separate like this. Okay, so the picture will be like this if we take the two like charges. But if we take positive or negative, then the electric field lines will draw like this. Okay, so what do you mean by lateral pressure here? Pressure, I think you all know the word pressure, but lateral pressure means that the pressure that exerts longitudinally. If we have any surface, that pressure that will exert longitudinally or in the horizontal direction of this surface, that pressure is known as lateral pressure. Not in any inclined form, not in any vertical form, it will apply laterally. So that's why it gives the name lateral pressure. I think all points are very clear. I will repeat all the points. So our first point is these lines are continuous and they never form the closed loop. Okay. The second point is no two electric lines will cross each other because at the point of intersection there will be two tangents and it is impossible that at particular point there will be two directions of electric field. Our third point is tangent to any point of the curved electric field, that tangent will give the direction at that particular point. So with the help of tangents, we can find out the direction at particular point. Okay. So these lines always start from the surface of any conductor or always end on the surface of any conductor normally. That means at 90 degree. Our next point is electric field lines always exert lateral pressure when we take the system of two like charges, because if we taking the two like charges, there will be the force of repulsion between them, and because of force of repulsion between them, these lines will exert lateral pressure. Because of this, we can draw these lines like this in the system of two like charges. Okay, so I think all the points are very, very simple and I have cleared all the points. What is the meaning of these lines? Please take a screenshot of it. If you have any queries, any doubt, you can comment me and you can message me. I will of course clear your points. So for today's, I think it is enough, the properties of electric field lines. So for the next time, we will meet with the next topic. Thank you. Bye-bye.